Concave mirrors can be thought of as being made from the silvered inside of a sphere. If we look at a sphere that was silvered on the inside and chopped off a section, we would have a concave mirror. The line passing through the center of the sphere, meeting the mirror at the exact center of the mirror, is the principal axis. The point in the center of the sphere from which the mirror was sliced is known as the center of curvature, and it is denoted by the letter C. Sometimes a figure of 2F is used at this point instead. The point on the mirror's surface where the principal axis meets the mirror is known as the vertex, V. The vertex is a geometric center of the mirror. The distance from the vertex to the center of curvature is called the radius of curvature, represented by capital R. The radius of curvature is the radius of the sphere from which the mirror was cut. Midway between the vertex and the center of curvature is a point known as the focal point, or principal focus. The focal point is denoted by the letter F. The distance from the vertex to the focal point is known as the focal length, small f. As the focal point is the midpoint of the line joining the vertex and the center of curvature, the focal length is 1/2 of the radius of curvature. We can use the following 3 facts to construct ray diagrams for curved mirrors. Number 1. Any ray traveling parallel to the principal axis on its way to the mirror will pass through the focal point upon reflection by that mirror. Point 2. Any ray passing through the focal point on the way to the mirror will travel parallel to the principal axis upon reflection by that mirror. The third point is that any ray that passes through the center of curvature of the mirror will reflect back along its own path, because the radius of the circle will always hit the edge of a circle at 90 degrees. As the ray hits normally, the angle of incidence and reflection will both be 0, and it will return along its original path. I will now lead you through constructing a ray diagram for a concave mirror. First, draw the principal axis across your page. You need to do that for all diagrams of mirrors and lenses. Using a compass, draw the curved mirror so that it is bisected at the principal axis. Ray diagrams are drawn to scale, so whatever value you are given for the focal length of the mirror will need to be doubled for the radius of the circle that you draw for the mirror. Now add the chevron shading at the back of the mirror. Label the point that your compass went through as C, or 2F, and the point where the line of the principal axis cuts the mirror, capital V. Measure CV and put a point F halfway along the principal axis. Place your object point to scale on your diagram. Add an arrow going from the principal axis to that point, just pointing towards it. Now take a ray from the object through 2F or C to the mirror. Add 2 arrowheads on it in opposite directions. Now take a ray from the object point traveling parallel to the principal axis and make it hit the mirror. Don't forget to add the arrow. Now make it reflect so it passes through F. And again, add the arrow to your reflected ray. At GCSE, those 2 rays are enough to get you the full marks. But if you want to be 100% sure that you have drawn it correctly, do the 3rd ray, and you should find that that will meet at exactly the same point. Take a ray from the object through F on its way to the mirror. Now add the arrow. Make it reflect from the mirror so it travels parallel to the principal axis. If you have drawn your diagram really carefully, all 3 rays will cross at one point. That is your image point. Label it and then draw an arrow going from the principal axis to that point. That is how to construct a ray diagram for a concave mirror. See Cyberphysics for more information. I hope that was helpful. Bye for now.